So do we recognize what's on our warm-up today? No, I'm not ending a sentence with an exclamation mark. It's actually a mathematical concept. What is it called? Good, Jenny. A factorial. Very good. Very good. Yep. So on number 1, I'm asking you to evaluate 5 factorial. So what most of you already knew this, but not everyone knows this. 5 factorial is 5 times 4 times 3 times 2 times 1. That is the definition of 5 factorial. It is the number times the number minus 1 times that number minus 2 times that number minus 3, so on and so forth until you get to 1. We are not going to multiply it times 0 because then that would just cancel out all of our hard work. Do you know, Quan, we're going to use factorials today. This math uses factorials. Probability does. We'll get into it today. Do you know where the factorial button is on your calculator? Just in case you're ever having to do like 20 factorial and you don't want to sit there. Do y'all know where to go? So on your calculator, you would do 20 and you would do math, and then you go over to the one that says probability, PRB, because that's our short little unit we're about to do. Probability. And then do you see the factorial? It's number 4. And then the calculator will evaluate it for you and get a nice huge number because 20 factorial is huge. We will get into what permutations are in a minute, Quan. Okay. All right. So on number 2, something interesting happens if you write this out by hand. 4 times 3 times 2 times 1. 3 times 2 times 1. What happens? Cancel, cancel, cancel. And so 4 factorial divided by 3 factorial is really just 4. It's 4. So what was this first one? 120. And this one's just 4. Okay. And then the last one, 6 times 5 times 4 times 3 times 2 times 1. Yikes, I ran out of room. Over 3 times 2 times 1. 2 times 1. 3, 2, 1. So it's really 6 times 5 times 4 divided by 2. You don't really understand what number 3 is saying, but that's actually a formula that we're going to use today, and we'll understand what it applies to later today. That's actually 6 combination 2. So it's when you have 6 things and you want to choose 2 of them and order doesn't matter. That's what number 3 is. Is it 6C, Helaman? Yeah, this is fun. You're really going to like this super short unit. Okay? So let's get into our notes. There's no homework to check, obviously. I'll show that at the end, I promise. Maybe. I always promise. If it's a bigger number, does the factorial get smaller? If it's a bigger number, does the factorial get smaller? No. The bigger the number, the bigger the answer. You're multiplying more things. So, has anyone ever been to Small Cakes? It's really good. It's on 1960. I'm not like promoting them or anything, but if you want like a gourmet, really cool, unique cupcake, you go there. 0 factorial is defined to be 1. Yes, George. Very good. 0 factorial is 1. It's interesting. Okay, so anyways, so if you go into Small Cakes and you want to order your own cupcake, and usually you just buy one of the ones that's already made because they're beautiful and they taste delicious, but if you wanted to order your own and these were your choices, how many different cupcakes could you create? How do you put this one in our calculator, Quan? Well, I'm just letting you think about it first, and then I'll tell you. This one's not a factorial. It's not. So the way you would go about this the long way is you would say, okay, I could choose chocolate, and then I could pair it with each one of these. You could make a tree out of it. And then if I did chocolate buttercream, then I could have each one of these. But then I'd have to do this, and it would get really messy really quickly, right? So the short way to think about it is, good job. Yep. You literally just multiply your different options in each category. So the way to find how many cupcakes you can create, there's 3 cake options, there's 5 icing options, and there's 5 topping options for a total of 75 unique cupcakes that you could make. That was interesting. Okay? So today we're not really going to talk about what's the probability I choose a red velvet with caramel and Oreos on top. That's not what we're talking about today. Today we're just going to talk about how many different ways you can order things, how many different ways you can choose things. Then tomorrow we'll start to get into a little bit of probability. All right, so if we could do that one, then we can definitely do this one. You're going to make a yogurt parfait. You choose 1 flavor of yogurt, 1 fruit topping, and 1 nut topping. How many parfait choices are there out there? Same thing we just did. So how many choices? Who's going to type it first? Who's got the fastest fingers? All right. 2 times 1, 2, 3, 4, 5 times 3. 30 combinations of parfaits. Okay. You are asked to make a password, which we are asked to do on almost a daily basis, right? Every time we sign up for something. It's got to have 5 letters followed by 1 number. How many possible passwords could you make? So go ahead and think about that. While you're thinking about it, I'll show you the worst passwords list. It says of 2012. I'm sure it applies anytime. Number 1 worst password is password. And then 1, 2, 3, 4, 5, 6. And then ABC 1, 2, 3. And then QWERTY, you know, like QWERTY on the top of your keyboard. And then let me in 111111. Dragon, I don't know why that made the top 10. Dragon, monkey, baseball, I don't know. Anyways. Infinite, no. It's not a factorial. It's not a factorial. So what you need to do is talk about how many slots are there. 5 letters followed by 1 number. So in your password, there are 6 slots. So these are just my slots. You need to go 1 slot at a time and ask yourself how many possibilities are there for that 1 slot. So for slot number 1, we need a letter. How many choices do we have? 26 choices. Does it say anything about you're not allowed to repeat a letter? In a password, are you allowed to repeat a letter? Sure you are. So in the second slot, there's, I didn't make it big enough, 26 choices, 26 choices, 26 choices, 26 choices. But what about, why did I do, I know, I saw it, 1, 2, 3, 4, 5, 7, that's awesome. Okay, 1, 2, 3, 4, 5, 6, I can count. So how many choices are there for that 6th slot? It needs to be a number, not 9. I did it on my calendar too, Adriana. Okay. 10, Jenny, very good. So there are numbers 0 through 9. If you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 10 different options. 0 through 9 is 10 numbers. So what is that really saying? That is 26 to the 5th times 10. 26 to the 5th times 10. (26 to the 5th times 10). So there are 118,813,760 different combinations of passwords that you could come up with. Lots of options. All right, now we're going to get into the actual vocabulary of today's lesson. Permutations versus combinations. So I want you to write this down if you're taking notes today. A permutation is something when you're choosing things in the order matters. So a license plate number, the order that you put those letters and numbers totally matters. So CK3H547 is different than KC3H547. Do you agree that I used the same letters and numbers, but if I switch those first two, that's a completely different license plate? Whereas if I'm just choosing marbles from a bag, if I choose a red-blue, and I have a red-blue in my hand, that's no different than choosing a blue-red. Red-blue and blue-red are not different combinations. So a combination is when order does not matter. Order does not matter. And permutations is when order matters. So permutation, order matters. Combination, order does not matter. And we'll get more into that in a minute. So we have three objects. How many ways can we arrange them if ... order matters, order does not matter? Weird things are happening in Adobe Connect. Okay. Oh, okay, Helaman Holmes. Okay, so anyways, if order matters, I can arrange them A, B, C. I can arrange them A, C, B. Do you get the idea? How many ways? So if order matters, I can arrange them in 6 ways. Now, if order doesn't matter, I mean, if I've got 3 letters, I'm choosing 3 of them, there's only 1 way. So this is our permutation, and this is our combination. So when you're talking permutation versus combination, there's always many more permutations than there are combinations. There's always less combinations, more permutations. All right, so let's do this. Actually, I'm going to change these numbers. I want to select 3 people out of you guys. So I want to select 3 people out of 14 because there's 14 of you signed in right now. So how many permutations are there if I want to select 3 of you out of 14? I volunteer as tribute. Oh my gosh, so funny. Okay, so there's 3 slots. Only 3 people get picked. How many people do I have? How many options do I have for slot number 1? Well, there's 14 of you, so I have 14 people to choose from. Now, if I choose a person, can I choose that person again? No. So for my second slot, I've got 13 choices. And then for my third slot, I have 12 choices. Okay? So there would be 14 times 13 times 12, whatever that is. Did you figure it out? 14 times 13 times 12 choices, 2,184 ways that I could choose 3 of you. That many different ways. Now, there's actually a formula out there for permutations. Let me show you the formula. I don't know if that's the next slide or not. I'm going to actually get to that in a second. I want you to write the formula down first, and then I'm going to show you how the formula works and why the formula works. So go ahead and write this formula down, and then I will further explain the formula. We're going to get to combinations. Don't worry, AG. We're just doing one at a time. So let me show you how this would work with the example that I gave you. So with the example I gave you, there were 14 of you, and I wanted to form permutations, but I was choosing 3 of you. 14, permutation 3. So What that means is you take the n and it goes in the numerator, 14 factorial, over 14 minus 3 factorial. 14 minus 3, so that's 11 factorial. So wait a minute, if I've got 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 in the numerator, and I've got 11 on down in the denominator, which numbers are going to cancel? 11, 10, 9, 8, all of those are going to cancel. So if 11 and on cancel, what's going to be left in my numerator? 14 didn't cancel, 13 didn't cancel, and 12 didn't cancel. The rest canceled. So do you agree that that's exactly how we worked that problem? 14 times 13 times 12. So that is how the formula works. I'll show you the slide just from the book, so the writing's not all pretty. But you can use factorials to find the number of possible permutations. So go ahead and look at this. This is exactly what we did, except we did 14, choose 3 instead of 7, choose 4. So the total number of arrangements would go on top. If you want to say, how can I arrange 7 people, you do 7 times 6 times 5 times 4 times 3 times 2 times 1. But then you want to take out 4 times 3 times 2 times 1 because you're only choosing 3 people. So this is 7, choose 3. We want to take out all of the other ones because we are only choosing 3 people. So that's how the formula works. So you can think of it as the way we did it here, or you can think of it as 14, choose 3. Now, is that in your calculator? I bet you saw it when you were about to do factorials. So I want you to go to your calculator. Go to your calculator and put 14 in there. 14. And then do math. Go over to probability. Do you see the NPR? Makes me think of the radio station. Okay, anyways. 14, choose 3. Whoa, that's the same exact number we got. So you don't ever have to really do that formula by hand because there is a button on your calculator that does it for you. But do you need to understand what that button's doing when you press it? Absolutely. Do you have to do it by hand? Not necessarily. Okay. Mosey right along. Okay. So we've got a student council. There's 6 people on student council. We're going to vote for 3 positions. President, vice president, 4 positions. President, vice president, secretary, and treasurer. How many different ways can we choose those 4 positions from 6 people? So every time you're asked a problem like this, you always need to ask yourself, does order matter? Does order matter? If Adriana is the president and Albert's the vice president, is that the same as Albert being the president and Adriana being the vice president? No, that's not the same. So since you're giving them titles, since they have a title, the order does matter. So we would not choose combination, we would choose permutation. So there's 6 people, permutation, we're choosing 4 positions. If you plug that into the formula, that would be 6 factorial over 2 factorial. Or if you did it like we did the first time, there's 4 positions. For president, how many choices do you have? 6 choices. Well, now I've picked someone. So for vice president, how many choices do I have? 5. For secretary, there's only 4 people left to choose from. And then treasurer, there's 3 people left. So it doesn't matter which one you like better. Whether you like just thinking about each slot or whether you like choosing a formula like the permutation formula. Okay? Either way, what do you get? 360, the number of degrees in a circle? Very good. Cool. How many ways can a 2-digit number be formed? By using only the digits 5 through 9 and by each digit being used only once. I'm letting you think about it. It's only a 2-digit number, so it's not too intimidating. Okay, so how many numbers are there 5 through 9? 5, 6, 7, 8, 9. So it's really 5 numbers, right? So in my first slot, I've got 5 choices. In my second slot, I've got 4 choices. Very good. Total of 20. What if we wanted to do that the formula way? 5, and then we're choosing 2 of them. All right. That's the same as saying 5 factorial over 3 factorial. I just want you to be exposed to all the different ways so that you can easily switch between them. It's like showing you decimal to percent to fraction. I want you to see all the different forms so that you know your options. All right, a combination is a grouping of items in which order does not matter. There are fewer ways to order things when order does not matter, and we already talked about that. Here's your formula for combinations. This looks exactly like the formula for permutations, except something else snuck in the denominator. So this is the only thing different between the two formulas. I wonder why that's there. I want you to think about it. So let's say I had 10 people and I wanted to choose 2 of them. If I did the permutation formula, it would be 10 factorial over 8 factorial. But the thing is that if I don't care the order, if I don't care if it's Quan Yeji or Yeji Quan, then I need to divide it by 2 because I don't want Quan Yeji to be the same as Yeji Quan. So I want to divide out all the Yeji Quans. Does that make sense? So I need to divide it more than just by 8 factorial. I need to get my permutation, but then I need to divide my permutations by 2 because I don't want AB to be different than BA. I hope that kind of makes sense where the formula comes from. Okay, we already talked about that. All right, for each of these examples, step 1, you need to decide permutation or combination. And then step 2, you need to actually evaluate the permutation or combination. The swim team has 8 swimmers. 2 will be selected to swim in the first heat. How many ways can the swimmers be selected? They're not drowning. Permutation or combination? Does order matter or order not matter? I agree with Minjung. I think the order does not matter. Because if I pick Minjung Tahani to swim in the first heat, so Minjung and Tahani, they're swimming in the first heat. Is that different than if I choose Tahani and Minjung to swim in the first heat? Is that a different combination of people? No, it's no different. It doesn't matter whose name I say first. Those 2 people are going to swim in the first heat. So the order that I call the names does not matter. So this one, the order does not matter, is a combination. There are 8 swimmers and you're choosing 2 of them. So go to your calculator, type in 8, go to math, go to probability, go to combination, and then 2. There are 28 ways. Okay? Order does not matter on that one. Katie is going to adopt kittens from a litter of 11. How cute are those kittens? How many ways can she choose 3 kittens to take home with her? Yes, Yeji. Yes. Combination or permutation? Good, okay. It does not matter which kitten you pick up first. If 3 are going home with you, 3 are going home with you. Doesn't matter which one you put in the basket first, right? So there's 11 choices. We want combination. We want to take 3 of them with us. Brandon, that's N and that's R. N is the number of the options you have, and R is how many you want to choose. Did I answer? Sorry, whoever asked. N is the first number and R is the second number. N is how many options there are, and R is how many you want to choose. All right, so 11, math, probability, combination, 3, 165, yep. It's always good to do it by hand just to remember. So if we did it by hand, it would be 11 factorial over 3 factorial, and then what's 11 minus 3? So that's us plugging the numbers into the formula. That's what the calculator is doing when you press that mysterious button and a number just pops out. That's the operation that the calculator is performing. 11 factorial over r factorial, and then you subtract them factorial. Okay. Awards are given out at a costume party. How many ways can most creative, silliest, and best costume be awarded to 8 contestants if no one gets more than 1 award? I don't know what you're asking, AG. All right, so there's 8 contestants. Yeah, is it a permutation or combination? Since you are giving them titles, Helaman getting silliest and Jenny getting most creative is different than Jenny getting silliest and Helaman getting most creative. Those are different, so it is a permutation. So there are 8 contestants. We're doing a permutation. How many awards are we giving out? 1, 2, 3, right? 1, 2, 3. 56. No? 8, math, probability, permutation, 3. 336 ways. Remember, the number is always going to be larger when it's a permutation than when it's a combination. All right, your homework in this unit is quite lengthy. There's a front and there's a back. There's 2 pages. And so it will lead you through any question you could ever be asked about this. So please take time to start on your homework right now.